golf ball that hits. Here's your golf ball. And it forms these ripples, right? Okay, and it's just like when we were blowing up the balloons, at some point, it's like, okay, at the radius is 3 feet, we want to know what was the rate of this area of this circle changing, okay? So it was still increasing at that point, right? So it should be positive. All right, so what do we know? I'm going to highlight what we know here. What do we know? Give me one thing we know.
The circles are moving off this 3/4 speed per second.
Okay, so what is that?
Velocity.
Right, according to what are you going to really call, that is velocity, but you're not going to have an equation that has velocity in it. D something, because it's a derivative, dr dt. And r is radius, so your, it says, I mean, it's got to be radius, right? Can't be anything else. Okay, so that is dr dt equals 3/4 feet per second. Okay, where r, just saying, is a radius. We don't have to go crazy. You should, but I think it's assumed for this one. If you just call everything x, then yes, make sure you tell me what x is. Okay, but let's see. What are we looking for? The ADT. Okay, good. So that's the ADT is the rate of change of the area. So that's the ADT. Hello, what's happening? Come on. The ADT. Now it shows up. Equals what? What moment are we discussing here? When r equals 3 feet. Okay, so if I was giving you a credit for this problem, I would be looking for all this information, not necessarily this. I think radius is assumed to be r. So, and a lot of times on free response, if you've identified something that they want, even if you couldn't get to the end of it, they would give you some points for that. So make sure you identify what you know. Plus, it's sometimes very confusing because you're like, wait, I don't know what your R. What are you looking for? Okay, so that's step 1. Step 2 says write an equation that relates the quantities. Don't say it out loud, but everybody think about it. We got radius. We got area. I think there's an obvious equation here, Riley. What would it be? No, you were nothing. What is it? Okay. So there you go. There's your step 2. My extend page doesn't work too good. Probably slightly off. Okay. All right, Riley, you need to make sure you are listening, whether you're writing or not. Okay, now, step 3, differentiate. I'll give you a minute. That should be a piece of cake. Remember, pi is a constant. All right, so what you got, Ruby? Look. I'm still on the highlighter. All right, DADT. Nice. Okay. Okay. Very good. Step 3. Now we can plug in. All right. We can plug in after we differentiate. We don't have to, set it equal to, in this case, DADT is what we're looking for. So what do we got here? 2 times R is what? 3 feet. Okay, I'm putting my units in here. I'm trying to be a good science person, but it's not really my thing, but I'll do it once for you here. Feet per second. Okay, do the math. what do we got here? Something pi. 2 goes in here, say 9/2, 4.5, 4.5 pi, and what's my unit? Right, square feet per second. So the units should work out the way they're supposed to work out. I don't personally care if you put them in your math equation as long as you attach them at the end, but if you're going to forget that, then just leave them in there. Now, the only way they don't work out is if you have feet and then you have inches, so you would catch that if, once you put it in your equation. Yes, please.
If you have like 9 pi.
That's fine. That's fine. Yep. Okay, you could even write whatever 4.5 pi is. What is 4.5 pi?
Why is it 4.5?
14.137.
Why is it feet squared?
Feet times feet is feet squared. And don't forget its area.
Everybody says, is it your grind that many feet squared?
Right. Your area is always growing in terms of squared whatever. So it should make sense that your derivative, then the change in area should be in square feet per second. Okay, I don't care what you put that in. If it's multiple choice, your answers will be obvious to whether they use the pi like you should or they used it in exact form. It doesn't matter. Okay, sometimes this makes more sense. Tell me what that answer means in terms of this problem, Rachel. Right, and sometimes that makes more sense than 4.5. But the area at the moment when the radius is 3 feet, which is a pretty big, like from here to here, that's a pretty big ripple, right? Okay, and that's just the radius. I can't even imagine that it made those huge ripples. I don't know, but anyway, but that's the increasing at the moment, okay? All right, that's the radius, yep. Okay, so we're going to get harder. All right, a 12-foot ladder begins sliding away from base of a house at a constant rate of 2 feet per second. At what rate was the top of the ladder moving toward the ground when the base was 17 feet away from the house? All right, so got a house, very skinny one. They got a ladder. Okay.
This is base, right? Yeah. Okay.
Yes. Okay. All right, so what do we got going on here? 12-foot ladder. Is that ladder, as it slides away, is it going to change? Is it going to change size? No, so then I'm going to put 12 on here. Because that is not going to change. That is not disturbing my, because I don't want a variable there if it's not going to vary. I want a constant there because it's going to be 12 feet forever, even if it slides off and totally gets flat on the ground if that's where it ends up. Okay? So if it's a constant, then put the constant on the thing, otherwise you're going to make yourself crazy by thinking everything is a rate. It's not. Yes?
So, isn't the hypotenuse supposed to be a 1? So, if it's 17 feet away.
Just wait. All right. But that's sliding. Eventually it'll get right. Okay, so 12. So what else do we know? I see it 2 feet per second. What's that?
The growth of the base.
Happening. Makes me crazy. Yay. Okay. Now we did it 3 times. It shows up 4 minutes later. Okay, so we have a constant rate of 2 feet. Now, what do you think? First of all, this is when you have to say, okay, I think there's something happening here. It's very, we need a variable. What do you want to call it? B for base. Okay, so I'm thinking this triangle, okay, is going to change shape as this guy goes, you know, it comes down here and now it goes like this, okay, or if it comes down here and now it goes like this. You see what I'm doing? I'm changing that triangle as that thing, so that's all that's changing. So what really part of my original triangle is B? So from here to here is B. Okay, that's B. Just wait until we get everything identified, and then you can. Okay. All right. Now we also have 17 feet. What the heck? Oh, at what rate is the top of the ladder moving? So again, if you change this. Ladder starts sliding, and now it's, you know, like this. Everything changes. This little guy changes, and this is still 12. But this dude changes. This dude gets bigger. This dude gets smaller. Okay, the base is going to get bigger. Let's say now it's way down here. I'm exaggerating my 12 feet, but this is even smaller. This is larger. So the base is growing. What do you want to call this guy? The height. Okay. Which is right here. Okay. All right. So we got B. I don't know what's happening. It might be the, sometimes the pen doesn't like the, okay, I don't know what's happening, but it's making me crazy. Okay. So, Rachel, you still have a question?
I'm just confused about, I mean, I think this is theoretical problem.
Well, yeah, we can be. Why?
Because when it hits the ground, and it's away from the house, it's flat on the ground.
No, it's not yet. It's still sliding.
No, but it can't be, because it's sliding this way.
It is going to be.
Yeah. How is it?
Because if you take your,
the time was going to change, the hypothesis can change to be what is currently.
this is your last wrap.
Oh, sorry.
Okay. This is your house.
Yeah.
This is your ladder.
Yeah.
Okay. All right. So currently we have this that goes all the way down here. Okay. Now we start sliding. This is still 12. This is different now.
She's saying when the base is 17.
Oh.
How is that theoretical? Because it has to be theoretical, because there's no way. Maybe you just keep sliding it. Oh, because, no, because it wouldn't go that's going to get around. But they don't go on that. Exactly.
Right.
Yeah, and then it can never, but then the ladder's never going to be 17 feet. It will be. It won't be 17 feet on it. It'll stop moving. It'll stop moving. Because you know.
All right, here we go. Okay. Okay, so I need an equation to relate h, b, and 12. No, I don't yet. First of all, what do I know? Okay, wait, shh, go ahead. Okay, so what am I calling that in terms of what I, okay, dB dt is what? Okay. All right. The h dt when b equals 17. Was it? Yeah. Okay. So what's my relationship between h, b, and 12? What? Okay, away from the base of the house at a constant rate at 2 feet. So that's definitely that changing, is it not, Sabrina? Okay, you're good. All right. Okay, so what is it? Okay, so that's step 2, equation. Okay. All right. Now, what's step 3? Differentiate. Okay, Emily. So what? Because we don't care about the area. We care about d, h, dt. Area is not even a factor here. All right, go for it. Good job. Okay. I was expecting 2 times 12 and
I thought about it.
yeah, it's a constant. Okay, now, save yourself a little effort. Divide by 2. Done. Divide by 2. Divide by 2. Divide by 2. Still 0. Okay, so now can we plug in? What do we know? B equals 17. Okay, dB dt is 2. What's h? You can't have 2 question mark. dH dt is the question mark. Is it though? How? Okay. Yeah, and that's when it gets crazy. Okay.
Yeah, you can't have it.
All right. We take 57. It's so weird that I. Okay. Okay, sorry.
Do you remember in pre-cal when we were doing that?
Yeah.
I was like, this can't work.
Okay.
And they're like, I'll show you. It can work.
All right, find that h is b squared plus h squared equals 12 squared. Okay, so b squared is 7. H squared is, all right, so what's h squared? 49 from 144? Okay. That's good. Yeah, it's 95, isn't it? Okay. All right, so h is really what? Square root 95. Okay, I don't know what has happened to that. Oh, the ladder was supposed to be 25 feet. It's okay, we'll work it with 12.
That was gross.
Huh?
We have a
It's going to be gross anyways. It was gross with 25. It doesn't matter. Numbers are numbers. All right. Okay, so what do we got? Now 17 times 2, Ainsley. Your math skills are so good. 7 times 2 now. What is 17 times 2?
It's 7.
Oh, sorry. Okay, 7 times 2. What is it? All right. Finish solving.
Do we have to take the denominator? Yeah.
Well, you probably are going to take this to a decimal, so it actually is a million.
Okay.
Okay. So take it to a decimal just because.
You almost do your third.
Yes, ma'am. All right.
Is it?
I was like, that is so weird. That has never come up before. But that's like the opposite. That's low. Who knows? All right. We are ready. Mackenzie, do you have a rate for me? What is it? All right. I'm happy to say you are correct. I don't know. Would it be?
It would be square per second because you're multiplying.
No.
Because you're not multiplying.
So B was feet per second. And then V was feet. dB was feet per second. H was feet, so you're dividing feet per second by feet, you still have feet. Now let's think here. Right?
Your answer is feet per second.
Yes. Feet squared per second on this side divided by feet is still feet per second. Okay, now explain to me why we can have a negative rate. And direction, what does that mean? Okay, but in the context of this problem, why is DHCT negative? One person at a time, please. Ready? Right, because H is getting smaller, so the rate, it's rate. So watch that in the language when you're setting it up. If it says it's getting smaller, you better call it a negative rate from the beginning. But that should be, so, and sometimes they'll do this too. They'll say, how far, what is this? When the band, at what rate was the top of the ladder moving toward the ground? So they might call it a negative. They also will say it's moving 1.436 away from the ground. And then, you know, they might always not always call it negative. All right. You ready to get harder? We'll try to get this right. Okay. A hot air balloon. Yes. Rising straight up from a level field is tracked by a rangefinder. No, 500 feet from the liftoff point. Okay. At the moment, I had a few too many lumps in my arms, but you get it. The rangefinder's elevation angle is pi over 4. The angle is increasing at the rate of 0.14 radians per minute. Yikes. How fast is the balloon rising at that moment? Okay, I'm going to wait for, if I'm down here, my angle is here, and that's my triangle. If I'm up here, my angle is my red triangle. I could be here, but this angle, depending on where I'm looking at this from, is changing. So do not put your angle in that triangle. I'm going to get rid of my green line. Okay, you understand that? All right. Okay, so
Wait,
I'm
don't you have a specific angle?
Not in, no, because that's changing, yes, but that doesn't go in the figure. That goes in the data. Okay, so what do I know? What am I going to call? Let's see, what do I know here? The angle of elevation is at a moment, so what am I going to call your angle? So you're going to call this right here A?
Yeah.
Okay. All right, what else? When A is pi over 4, what are we looking for? How fast is the, so you're calling this H, okay? dH dt equals what? Okay, I did that a little backwards than I used to do. Okay, and I usually do. And then what rate do I know? dA dt is 0.014. Okay. No, sorry. All right. Okay. So, what is the relationship between H? A, don't say it out loud, please, so everybody gets a chance to think about it. You're looking for, that's step 1. Now, by writing this here, you have identified H as the height. By writing A here, you've identified A as the angle from the range finder to the 500 to the. Okay, so that step, all that is, would be point worthy on a test of mine, and more than likely free response problem. Okay, so step 2 is finding the equation that relates all that. All right, so we got an H, we got a 500, and we got an A. There's lots of them that we could use. I'm waiting for Mackenzie. What do you think their relationship would be? It's not Pythagorean theorem because we don't care about the hypotenuse. What else do we have to work with? Are you passing? 3? Okay. All right, so tangent of A, here we go again, equals what? H over 500, okay? All right, very good. Now you could have used, could we have used any of them? No, we had to use tangent because we have the opposite. I was thinking we could have switched that up. Could use cotangent, I guess. Technically. Okay, so go ahead and differentiate. Right. Remember, with respect to time. So you have a tangent. You don't remember the derivative of tangents. What is it there, Chunk? What is it? She doesn't remember it either? No.
Secant squared.
Okay.
Times. Oh wait, oh yeah, dA.
It's implicit. You got to put it in there. Or if it's not dealing with time, you got to stick it in there. Okay. And what is the derivative of H over 500 circle? Okay. How about just 1/500th dH dt? Now, if you don't like that, remember the 500 could go over here as a constant. You could totally make this 500 tangent A equals H if you wanted to. If you don't like that piece, if the division piece bothers you. Okay, so now we're ready to plug in. Okay, A is pi over 4. dA dt is 0.14. And we're going to end up taking the 500 over here to solve anyway, aren't we? All right. A lot of times you will. But not always no. I would say just use it moderately. wouldn't go crazy with it, but sometimes you get your calculator out too soon and you forget to keep these things sometimes.
Isn't it secret? Isn't it, two raffles?
You know what I have?
Oh, that's why.
Okay.
I don't know.
I don't either, but you're making me second guess myself.
Isn't that good? It's like,
No,
it's
okay.
it's like,
it's not good.
it's like top. It's like top two power area. I know.
What range is talking through power?
Is it all the same?
All right, this turns out decently considering. So what is it? Did you get 140? All right, and that is the per second.
Why is it?
Oh,
It is per minute.
That's why it looks like this.
Yep, that just, you can't not forget the square. Okay, so let's look at the dimensions because that's really kind of important. This DADT is in what? Radians per minute. Which remember, radians just kind of goes away. Degrees would not. And this, of course, is a value. So there's that. Anyway, you got feet, square, feet. And remember, height is in feet, so that should be. All right, it's supposed to be cubic meters per minute. What's that? Okay. The volume. Okay. And it's volume because it's a cubic units, so that will help. All right, what do we know about, where's the radius 2 meters? At the top, and that's not going to change, right? That's the shape of my thing, so I'm going to put that in there. This is blue. This is 2. Okay. What is the height? So that is this guy right here, right? 4 meters. Okay. All right. And those only go on there on the figure if they are constant. Please don't put the ones that are changing on there because that'll mess you up. All right. So what do we want to know here? Find the rate at which the water level is rising. What do you want to call that? Okay, so we're looking for DHDT. And where would you put H on this thing? Right here? Okay, that's H, okay, good. And when at that moment, what moment are we talking about? So when H equals 3, okay, cool, all right. So we already dealt with the cone already. We know the volume is, we gotta have volume 1/3 pi r squared h, right? Okay, start, go ahead and differentiate. And we're gonna run into a problem right away.
What's on? Well, you.
Okay, just do it, and we'll talk about how we can fix it. Okay. Let me do it real quick. This is me pretending I don't know that there's going to be a problem because you aren't going to know this. Okay. Now, we start plugging in. Get this. We could get R, right? Maybe. We don't have DRDT. We can't ever find a rate that we are given. I'm not even sure we could get, oh yeah, we could get No. We can't get dr either because we don't have enough information. We don't have volume. If we have the H, if we have an H, we can find volume or we can find R. Right. We can't find both. Okay, so this is not going to work because there's too many unknowns at this moment. Yes.
Isn't it, it'll be a similar, no.
Yes, it will.
The entire cone has a height of 2. Or it has a height of 4 and a radius of 2. And you set it up so that if you know the height is 3 at that moment, then you
So
know.
4 is to 2.
As
3 is to 3 is to R.
and then
Okay,
you get
yes.
that R is.
Okay. So 4 is to 2 as 3 is to R. Everybody get that?
Yeah.
Okay. All right. I don't think we want to use 3. 3 is already plugging in what our thing is. I think we need to use H, don't we? This is the moment. Nope, nope, nope. That's not going to give us what. I think you're getting ahead of yourself a little bit, but you got the right idea. But let's use H here. Because what happens is we're going to have to take 2H equals 4R, right? We're going to have to replace this from the beginning because none of these are showing up.
Oh, so you have to replace.
So we're going to replace R with what? Right, 2H over 4, which is H over 2. Okay, so, no,
Basically, you have to make sure that you don't have the DRDT. In order to do that, you have to eliminate. You have to substitute in for R.
yeah, if R is not there and it's replaced with an H, all we have is H and we have everything we need. So I'm going to basically start over with my and replace R with H over 2. Okay? Before I even differentiate, because when I differentiate and R shows up in a DR, DT, which I don't have either. Okay, so let's clean this up. Let's see, what's H over 2 squared times H? H squared, H cubed over
Oh.
okay, which is really something times H cubed, right? What times H cubed in terms of a constant?
1. Oh, it's 1 12.
When the pi just goes away?
Oh, I didn't. You meant the entire. So it's 112
9 over 12? Okay, so this is my volume. This is my new volume equation with R gone. Now, that's going to happen occasionally that you're like, wait, I don't have enough information. You are never going to be able to come up with a dr or a derivative if you're not given it. So it has to disappear. All right, so now what's dv dt equal to, Sarah Chung?
So every day I'm still learning.
Okay. Whenever you're ready.
So
Different. You're differentiating this right here.
So DT would be equal to pi over 4.
12.
Pi over 12 times 3h squared dh.
Okay. And then you might want to make that pi over 4. Before you plug in, maybe it's up to you. Okay, good work. Okay. So H is what now? And DBD2 is 2, right? So this is 3 squared, and our DHDT is unknown. All right, go ahead and finish it to a decimal, because there's a tricky piece to this.